In this video, we will be deriving the expression for the frequency of emitted radiation when an electron makes transition. Simply from the postulate of Bohr model, if you remember, whenever an electron makes transition, suppose there is an electron in this orbit, it is making transition from this lower orbit to higher orbit. Obviously, it will absorb some radiation, and if one is N1, N2, N3, if it makes transition from the upper orbit to the lower ones, then it will radiate the energy in the form of radiation. So what will be the frequency of such radiation emitted? That is what we need to calculate here. So if you remember from the last video, I have derived an expression, this one. En equals to minus Me4 divided by 8 epsilon naught n square h square. Obviously this expression looks very weird, or we may say very long and complex to remember, but still it is easier to derive if you have seen that video properly. I will use this expression to derive frequency of emitted radiation. Let me write it here. Again, En equals to minus Me4 divided by 8 epsilon naught square n square h square. And I know that delta E is equals to h nu. It means nu can be written as delta E divided by h, and hence nu is frequency equals to En2 minus En1 divided by h, where N2 energy in N2 orbit is greater than En1. So I will put the values. Nu equals to minus Me4 divided by 8 epsilon naught square h square in bracket 1 by N2 square minus 1 by N1 square. This is the expression which we get by putting the values of En2 and N1. Just replace this n by N2 and N1. You will get this expression. Very important expression. Now we know this nu can be written as C upon lambda also, or we can write 1 upon lambda equals to nu by C, that is minus Me4 divided by 8 epsilon naught square h square C in bracket 1 by N2 square minus 1 by N1 square. And from here we are getting a new quantity, that is simply the wave number nu bar 1 by lambda, and this whole constant, this one, is a constant quantity which we call as Rydberg constant. Written as RH simply. I will write RH 1 by N2 square minus 1 by N1 square, and the value of this Rydberg constant comes out to be 1.091 multiplied by 10 raised to the power 7 meter inverse, as its units will be equals to this one, units of the wave number. And this formula is useful for all the hydrogen like atoms. Such as He positive, that is doubly ionized helium, Li positive, then comes beryllium tripositive, and etc. And as you can see, these all are ions, not atoms actually.